Hello everybody and welcome to Chapter 3, Section 3, Graphing Quadratic Functions in Standard Form. Our essential question is, how can you find the vertex of the graph of a quadratic function in standard form? F of x equals ax squared plus bx plus c. So as you can tell, this is a very familiar form, as in our previous chapter we learned about polynomials. So this is basically a polynomial written as a function. We call that quadratic. What we're going to learn is to identify the characteristics of a quadratic function. We're going to graph a quadratic function in the form f of x equals ax squared plus bx plus c, and we're going to find the minimum and maximum values of a quadratic function. All right, so to start off, we're going to identify some of the characteristics of a quadratic function. This shape here is the graph of a quadratic function. This quadratic function graph is called a parabola. Okay, that is the name of this shape. Now, a parabola is shaped like a U. So it's a U shape. So if you think back to chapter 1, we had something else that is a V-shaped. That was an absolute value. A parabola is a U-shape, and it is a parabola that is the result of a graph of a quadratic function. All right, so we're going to talk about a few things here and some of the characteristics. So vertex, we're going to start with our vertex. So our vertex is the point where our graph changes direction. So if we see here, the graph, if we're going from left to right, is going down, and then it starts going up, okay, at a given point. That point there is our vertex. All right, so to identify our vertex, we always use a coordinate pair. So an ordered pair in parentheses. So we use our x value first, which would be -1. And then our y value is -2. Okay, that is our vertex. Okay, so that's what we would fill into that first box. In addition, okay, our parabola is also symmetric. So I color-coded this. So the red side and the blue side are symmetric to each other. That means that it is the same on one side as it is on the other. And when there is symmetry, there is always a line that kind of divides the two halves. And this is our line of symmetry, our axis of symmetry. So this orange line that I just drew, so if we look at the two sides, if I pick like this point here, it's going to have an identical point directly on the other side at the equal distance. So if you see 1, 2, 3 squares to get to that axis, 1, 2, 3 squares or units to get to that other point on the other side. So every point on one side of the parabola is the same as a point on the other side. Okay, so this is our axis of symmetry. Now we're going to represent this using an equation. So our axis of symmetry is the equation of a line. So this is a vertical line. So how we write it, this line is passing through our x-axis. So I'm going to call this AOS, axis of symmetry. So it's passing through our x-axis, and it's passing our x-axis at exactly or equal to -1. So our axis of symmetry we write as x equals -1. Okay, because this line that I drew is passing through the point or the number -1 at our x-axis. Okay, so that's the equation of our axis of symmetry. Our graph, as we mentioned at the beginning, to find the vertex, right, is decreasing and increasing at some point. So the red side is decreasing, it's going down from left to right, and our blue side is going up from left to right. So we have a part of the graph that's going up and a part of the graph that's going down, increasing, decreasing. So what we're going to do here is we're going to label these two parts. So this side over here is increasing. This side over here to the left of our axis of symmetry. Notice how to the left the orange line, the axis of symmetry. the graph is decreasing. And to the right, we have an increasing function. So what we're going to do here is we're going to represent this in a similar way that we did our axis of symmetry, except we're going to represent it. We're going to use the same variable, x, and the same number, -1, x, and -1. So from this line, -1, from the y-axis, we want to indicate that the left side is decreasing and the right side is increasing. So we're going to use our inequality symbols. So to the left side, we have a decreasing function. So we're going to say less than, because less than means to the left of -1. And for increasing, we have greater than. Okay, so to the right is where we're increasing. So our increasing domain is x is greater than -1. And our decreasing domain is x is less than -1, so to the left. The last part we're going to identify here is our range. So our range represents the y-axis. So I'm going to do a similar thing that I did. So I'm going to go ahead and just draw a line here. This is where the graph kind of cuts off, right? So if you see, the graph is only above this line. Okay, it's above this line. There's nothing below the line, right? There's that red and blue graph that we started with originally does not go below this line that I just drew. So this is going to be our range. So we say that our range is above this green line. Okay, so in this case, our line is passing through the y-axis. So I'm going to use y. It's at the number -2, okay, and we're representing up. So we want to represent it using an inequality symbol, and up or greater, we're going to use our greater than symbol. So our range is y is greater than -2. All right, so here we have our standard form of a quadratic function. Okay, we have here our parent function. If we change our b value, okay, notice what changes with the graph. Okay, notice what doesn't change. Okay, so if I change b, looks like my axis of symmetry, or that green line, is changing. And so is that top right equation. So you see x equals, and then for whatever value I pick for b, looks like the numerator is changing. I'm going to leave it at 4. If I change c, looks like my graph is just going up and down. But c looks like whatever number c is, that's where the graph crosses the y-axis. So c is 6 right here. Notice how the y-intercept is 6. 6.57, -1.52, see? So C represents our y-intercept. Let's leave it at 3. And then A is also changing our axis of symmetry and the top right equation. See how that number in the parentheses is changing with whatever I put? Okay, oops. And when it's negative, looks like we're flipping our graph over, just like absolute value functions. All right, so we're going to go ahead and take a look at those in our next few examples. All right, so the first thing we're going to learn how to do is how to find the axis of symmetry. So how to find the equation of this line in green. So as you can see, at the top right of this graph, we have an equation x equals and then some numbers. That is the equation for finding the axis of symmetry. Okay, so to find, let's use green again for axis of symmetry. So AOS, I'm going to keep using for axis of symmetry. So my axis of symmetry, I can find by using the formula x equals -b over 2a. Okay, this is how we find our axis of symmetry. So we have our function 2x to the power of 2 plus 8x minus 1. So what we're going to do here is label this just how we labeled our polynomial expression. So that's our A term, that's our B term, that's our C term. So to find our axis of symmetry, we're going to go ahead and substitute our B and A from the function. So B is positive 8. So I'm going to put that up at the top of our formula here. And in the denominator, I have A, which is A2. So I'm going to go ahead and substitute that. And I'm going to go ahead and just simplify this. So I'm going to get negative 8 over 2 times 2, which is 4. If I simplify that, it's going to give me negative 2. So my axis of symmetry is x equals negative 2. And that's how we write it. We always write it as an equation for our axis of symmetry. All right. Okay, so if we go back here, if we notice, no matter what happens, okay, no matter what changes, our axis of symmetry always goes through that point right there, which is our vertex. Okay, and no matter what our axis of symmetry is, let me change it to something a little bit more whole right there. Okay, the axis of symmetry, which is -1 right here, is also the first value of the coordinate for our vertex. So if that's always the case, then what I'm going to do is I'm going to actually take my number that I just found, -2, and I'm going to substitute that into my function. So that number that I just found, -2, I'm going to replace it, substitute it into the function so that I can find the y value of the vertex. So I'm going to do my exponents. So then I'm going to keep my 2 down here. Plus 8, -2 stays, -1, bring it down. The only thing that changes is that exponent there. So it's going to become -2 to the power of 2. -2 times -2. Negative times a negative gives me a positive. I'm going to go ahead and multiply these two, multiply these two. That's the next thing in my order of operation. So I have 8 minus 16, because positive times a negative. And then bring down my 1. And then all of this is adding and subtracting, so I can do that all together and give me a -9. So -9 is our function value, which represents our y. So my vertex is -2, which is from our axis of symmetry, the number we substituted as well, and comma, -9 is our y value. So our vertex is located at -2, -9. All right, example number 3, graphing a quadratic function in standard form. Okay, so now we have the next step, but we needed to know that previous stuff in order to be able to graph it, because the first thing we have to do, so I've labeled the steps right here. The first thing we have to do is find and graph the axis of symmetry. So I'm going to go ahead and write my function here so we can have it minus 6x plus 5. Let's label it. That's A, this is B, this is C. All right, so the first thing we have to do is find our axis of symmetry. So we are going to find our axis of symmetry. Axis of symmetry. So we find that by using our formula x equals -b over 2a. Okay, I'm going to substitute. Let's put this, set it up with the parentheses. And I'm going to substitute b at the top. So notice how b is a -6. So I'm going to bring the negative sign with it. And this is very important that you carry the sign with the term. And then a is a positive 3. So what happens here, we need to make sure that this is every sign is brought with its term or number, because negative times a negative is a positive 6. And if we wouldn't have brought that negative, we would have been wrong when we were trying to graph this. Okay, so this would become 6 over 6, which is 1. So then our axis of symmetry is x equals -1. All right, let's put that in here. X equals -1. Okay, so that was our part of our first step. Now we're going to graph it. Okay, so let's put it in green. All right, so we need a line passing through the x-axis at -1. Okay, that's how we draw our axis of symmetry. So there it is. All right, we're done with step number, oops, got a mistake there. It should be a, not a -1, a +1 because it's 6 over 6. Okay, so gotcha. So it needs to be a line passing through the x-axis at +1, not -1. Okay, good thing I caught that right before I went on to the next step. Okay, so next we're gonna find and plot the vertex. Okay, so to find and plot the vertex, like example number 2, okay, we're gonna need to substitute this 1 into our function. Okay, so I'm gonna go ahead and write my function, but instead of the x's, I'm gonna put parentheses so that I can substitute my x value. And my x value was 1, a +1. Okay, I'm gonna do the exponent. One to the power of 2, 1 times 1. I'm gonna do my multiplication, 3 times 1, -6 times 1. That's 3 minus 6 plus 5. And then my last step is to add all these together. So that's going to give me a +2. So my vertex is 1, 2. 1 from the number I substituted and 2 from the number that I got from substituting. So my vertex is located at the point 1, 2. Okay, which if you did it correct should land right on the axis of symmetry that we already drew. All right, step 3, we're going to use the y-intercept to find 2 more points on the graph. Okay, so that's going to be fairly simple because if we remember from when we were moving the things left and right, oh, is that right here? Yeah, right here. The C value, whatever C is, that's our y-intercept. So you see 0, 5, 0, 6, 0, 7, 0, 7.5, 0, -6, 0, -5.5. So when we're here on the graph, our y-intercept is going to be 0, whatever our C value is. And our C value is +5. So our y-intercept is at 0, +5. So I'm going to draw a point on the y-axis at +5. Let me do it in same color. +5, right there. Okay, so we have pretty much everything that we're gonna need right here to graph, but we're actually gonna need one more point because we need the other side of the u. So, but what we know from parabolas or quadratic functions is that graphs are symmetric, right? From the left and the right, it should be the same. So it looks like I have 1 square to get to the axis of symmetry. So I'm going to draw another point, 1 square, to the other side of the axis of symmetry. So right there. And then I'm going to go ahead, and that's pretty much it, right? That's what step 3 says. Use the y-intercept, find two more points on the graph. So that's the y-intercept plus the one that's symmetric. And then I'm going to draw a smooth curve through the points. And I'm going to go ahead and change the color because check this out. If I use the same color, oh, actually it didn't do anything. I'm still going to change the color so I can highlight and see the points. Okay, so I want to make sure that I use the pencil tool, not the straight line tool, so that I get sort of like a curve. Try to make like a U shape. Try to avoid making a V shape as much as you can. It's okay if it kind of looks like a V, but it should look like a U. This one looks more like a V than anything, but that's okay. As long as you don't use the straight lines, okay, because the straight lines, this would not be correct. This would be very, very incorrect. Okay, so no straight line. Use the pencil. Make it look as curved as you can, as U-shaped as possible. Okay, and this is how you graph a quadratic function in standard form. All right, that is the end of our lesson. You should have learned about the key characteristics of a quadratic function. You should know what the constant c represents. You should know how to find the axis of symmetry. You should know how to use the axis of symmetry to find the vertex. And you should finally know how to graph ax squared plus bx plus c as a function. If you have any questions, comments, or concerns, please feel free to leave it in the comment section down below. Thanks for watching. See you next time.